After formulation of a linear programming problem, let us solve by some of the methods. The methods are graphical method, simplex method, two-phase big method. To solve the graphical method, as the constraints of the linear programming problem are all greater than or equal to 0, means x1, x2 are all greater than or equal to 0, the graph comes under the first constraint. G.J. Breweries Limited has two bottling plants, one located at G and another located at J. Each plant produces three drinks, whiskey, beer and brands named A, B and C respectively. The number of bottles produced per day are shown in the following table. We have drink and we have plant, that is at G and J. We have drink namely three, that is whiskey, beer and brandy, and then for plant J it is 1500 and for plant J it is 1500. For beer it is 3000 and 1000. For brandy it is 2000 and 5000. Let us continue the problem. A market survey indicates that during the month of July there will be a demand of 20,000 bottles of whiskey, 40,000 bottles of beer and 44,000 bottles of brandy. The operating cost per day for plants at G and J are 600 and 400 monetary units. For how many days each plant be run in July so as to minimize the production cost? Okay, we have two plants, plant G and J. So the decision variables will be x1 equal to number of days of work at plant G and number of days of work at plant J. At the operating cost for these two plants has been given as 400 and 600 and 400. So objective becomes minimize z is equal to 600 x1 plus 400 x2. And the constraints will be 1500 x1 plus 1500 x2 greater than or equal to 20,000. 3000 x1 plus 1000 x2 should be greater than or equal to 40,000. And 2000 x1 plus the 5000 x2 should be greater than or equal to 44,000. Converting all these inequalities to equalities, we get the following these. For the first constraint, this is the first constraint. For the first constraint, we are going to get x1 is equal to 13.33 and x2 is equal to 13.33. For the second constraint, this is the second constraint. For the second constraint, we will get x1 equal to 13.33 and x2 is equal to 40. And for the third constraint, we get x1 equal to 22 and x2 is equal to 8.8. The next step is we have to make the graphical and put all these coordinates on the graph. So after getting the coordinates for all the three constraints, you are going to have A is 1, 22, 0, 12, 4 and 0, 40. But how we are going to get this? By drawing in the graph page. On x-axis, we are going to plan on x1 coordinates. For y-axis, we are going to take it on x2 values. So for the first constraint, x1 was 13.33 and x2 was 13.33. So we are going to mark over here and then we are going to join this 13.33 and 13.33. Similarly, for the other two constraints, we are going to mark that. Okay, and then we are going to have this region because all the constraints are greater than or equal to. So if the constraints are greater than or equal to, we have to take the region away from the original. So in this case, this is also greater than, so I have shown over here, and this greater than or equal to, and this. So the feasible region, we are going to get this. After getting the feasible region, we have to find out the extreme points. So I have said this as A, this as B and this as C. So for these extreme points, the coordinates are 22, 0. For B it is 12, 4. For C it is 0, 40. After getting the coordinates, extreme points A, B and C, let us put in this format. We have extreme points, coordinates, objective function and the value. Objective function is minimize 600x1 plus 400x2. So the extreme points are A, B and C. Coordinates are 22, 0 for A, 12, 4 for B, 0, 40 for C. So we have to put these two in the objective function. So after getting the values, substituting the values in x1 and x2, we get the values as 13,200, 8,800, 16,000. But the objective of our problems is that it is a minimize. So select the minimum value among this. So minimum value is pertaining to extreme point B. So we have to select this. Then optimal solution. Optimal solution is x1 is equal to 12, x2 is equal to 4 and z minimum is 8,800.